We end here tonight with a sleeping giant, an ancient supervolcano beneath Yellowstone National Park. It has been snoring for thousands of years, exhaling through the park's famous geysers.
The Yellowstone region is known to be one of the most seismically active areas in the United States, with an average of 1,500 to 2,500 earthquakes occurring annually. Although most of these earthquakes are too small to be felt by humans, advanced monitoring technology can detect them.
Oh, it is shaking. That's a pretty good earthquake there.
The region's seismic activity impacts natural formations like gardens and lakes, as well as the area's economic growth. What kinds of earthquakes have been recorded during the last few decades? What kind of earthquake is the most recent? Join us as we discuss about the tremors in the Yellowstone region. Number 1. Earthquake in Yellowstone. A new tremor hits Yellowstone, Montana on Thursday at a magnitude of 3.3 at 1:10 a.m. No loss of life, property, or casualties has been recorded yet. The shock was felt throughout the city. The officials in charge are gathering data and reports on the area.
This is a very strong earthquake.
Pretty strong here.
8:21 here on the air. We're experiencing very strong shaking. Wow. I think we need to get under the desk.
Another magnitude of 2.6 happened 29 kilometers from West Yellowstone at 15:47. There was also the same recurrence on the same day at 15:36 and at the same location. There have been nearly 48,000 earthquakes in the Yellowstone region since 1973. Over 99% of the earthquakes have a magnitude of 2 or less and are felt by no one. There was only one magnitude 6 occurrence during that time, the 1975 M6.1 Norris earthquake at Norris Geyser Basin, the biggest earthquake ever recorded within Yellowstone National Park. There have also been 2 earthquakes of magnitude 5, 29 earthquakes of magnitude 4, and 379 earthquakes of magnitude 3. Yellowstone experiences an average of 1,500 to 2,500 earthquakes each year, most of which are so minor that they cannot be felt. However, significant earthquakes can and have occurred in the recent past. The Yellowstone system's earthquakes are primarily caused by 2 systems: the volcanic system, which stresses the crust, and the tectonic system, which is shown by a region of active stretching of the crust from east to west. The shaking is the product of a complex network of faults related to the volcano and adjacent tectonic features. Yellowstone earthquakes typically occur in swarms that are close in time and space. This scenario is connected to the transit of volcanic fluids over the many microscopic fissures in the shallow rocks over the ash observed in volcanoes worldwide. Earthquakes happen along crustal cracks when tension from crustal plate movement and volcanic activity is sufficient. The rock along these faults becomes stretched to the point of slippage or fracture. The energy is subsequently released through shock waves, echoing throughout the surrounding rock. It can be felt when a shock wave reaches the Earth's surface. The Earth is affected by surface waves, which can cause it to roll, split apart, or shift vertically and laterally. Structures are subject to earthquake damage because ground motion is mostly horizontal. Yellowstone earthquakes help to preserve hydrothermal activity by keeping the plumbing system open. Mineral deposition may plug the tiny cracks and conduits that supply hot water to geysers and hot springs if there is no periodic disturbance from relatively minor earthquakes. Some earthquakes induce changes in Yellowstone's geological systems. Earthquakes, such as the 1959 Hebgen Lake and 1983 Bora Peak, had noticeable effects on the Old Faithful Geyser and other water phenomena. Yellowstone frequently encounters earthquake swarms, a succession of earthquakes in a short period in a confined location. The greatest swarm occurred in 1985, when over 3,000 earthquakes were registered on the park's northwest side over 3 months. Hundreds of earthquakes were recorded during swarms in 2009 near Lake Village between Old Faithful and West Yellowstone. Scientists believe that the swarms are created by shifting and changing pressures in the Earth's crust, caused by hydrothermal fluid migration, a natural occurrence of volcanoes. Shocks aid in mapping and understanding the subsurface geology surrounding and under Yellowstone. Earthquake energy moves at various rates through hard and molten rock. By reading the seismic waves released by earthquakes, scientists may see the subsurface and create visualizations of the magma chamber and caldera. A comprehensive geological monitoring system is in place to aid with that interpretation. Number 2. History of earthquakes in Yellowstone. The greatest earthquake of 2017 struck at 6:48 p.m. Mountain Daylight Time on June 16th. The magnitude 4.36 earthquake struck 9 miles north of West Yellowstone, Montana. The earthquake was felt in the Montana communities of Gardner and West Yellowstone. It was the greatest earthquake since the 4.8 m on March 30th, 2014. On June 15th, 2017, at 5:48 p.m. local time, an event with a magnitude of 4 occurred. The 4.4 magnitude earthquake was felt by approximately 120 people in Yellowstone National Park and the nearby settlements, including West Yellowstone. This earthquake was part of a swarm of powerful earthquakes in the same area. The Maple Creek swarm began on June 12, 2017, and lasted until October that year. A cluster of over 2,075 earthquakes was detected 6 miles north of West Yellowstone, Montana, and on the park's west border. These types of earthquake sequences are prevalent and account for nearly half of the total seismicity in the Yellowstone region. The University of Utah, in partnership with the University of Texas El Paso and Yellowstone National Park, planted 290 nodal shock detectors in and around the Upper Geyser Basin in November 2017, as part of a study that began in 2015. The purpose of the temporary deployment, which lasted several days, was to record shock signals from diverse thermal characteristics. The 2017 study focused on Geyser Hill, attempting to discover the underground root of thermal phenomena and determine if they originate from a similar reservoir or separate sources. In 2015, similar maintenance was done on Old Faithful's plumbing infrastructure. A magnitude 7.3 earthquake shook the park on August 17, 1959. It claimed 28 lives as a landslide ripped through a campground and severely damaged the ingenious systems of neighboring Yellowstone National Park, notably Old Faithful Geyser. More than 80 million tons of rock fell, stopping a river and creating Earthquake Lake, which still exists today. The quake was the second largest in the lower 48 states that century at the time. It is still the greatest historical earthquake in the Intermountain West, bounded east by the Rocky Mountains and west by the Cascade Range and the Sierra Nevada. Sapphire Pool, a previously peaceful hot spring in Yellowstone's Biscuit Basin, began erupting over 200 feet high just a few days after the quake. The eruptions destroyed the basin's famous biscuit-like structures. Steamboat, the world's tallest geyser, erupted in 1961, less than 3 years after the 1959 earthquake, after a 50-year hibernation in Yellowstone's Norris Geyser Basin. The U.S. Forest Service opened the Earthquake Lake Visitor Center 8 years after the earthquake. The center is just across from the original slide, which is still visible today, on Highway 287. The center is located around 27 miles from West Yellowstone and is open from May to September. The fault scarp can now be seen north of Highway 287 in the Cabin Creek Scrap area, 23 miles northwest of West Yellowstone, and in Red Canyon, about 17 miles northwest of town. The trailhead is roughly a 10-minute drive from the Red Canyon turnoff, and the scarp is about a 20-minute climb away. The building destruction site is 21 miles northwest of West Yellowstone, on the north shore of Hebgen Lake. This little visited location is accessible by an ancient highway and a short walk to the buried Hillgard Fishing Lodge. The canyon's most visible feature, the slide, is still mostly barren, with scattered tree regeneration. Highway 287 provides a clear view of the harsh, barren mountainside. The trees that previously bordered the Madison River now lie gray and soggy at the bottom of Earthquake Lake, protruding from the surface as a reminder of what once was. Number 3. Overview of the 2023 earthquake. The stream activity was likewise at a low level. The fountain's water steamboat eruptions had declined, as they have since the record-breaking show in 2020, when 48 eruptions occurred. The fountains erupted only 9 times in 2023, the most recent on December 30th. But it wasn't just streams going to sleep in Yellowstone. On November 23, 2023, giant streams in the Upper Geyser Basin near Old Faithful erupted for the first time after multiple eruptions from mid-2017 to early 2019. The only notable water unrest occurred in May-June 2023, when previously dormant places on Geyser Hill and Old Faithful became active and new pictures formed. This caused a portion of the boardwalk in the region to be blocked by visitors. Hot water and debris spilled onto the walkway, but the activity quickly subsided and the boardwalk reopened in early August. The sequence resembled turbulence in the same general area in 2018 and serves as a reminder of the changeable character of Yellowstone's geyser basins. In contrast to earthquakes, ground deformation, and most water, Yellowstone Volcano Observatory scientists were quiet in 2023. The deposit's layering and the discovery of new geologic units attest to the intricacy of this massive eruption. The fountain steamboat was also investigated, with wood fragments from long dead trees lodged in the geyser's sinter deposits being dated. The wood ages suggest that the streams have been active for hundreds of years, significantly older than the 1878 origin date reported by Philetus Norris, the second superintendent of Yellowstone National Park, and the namesake of the Norris Geyser Basin. Furthermore, the ash chamber beneath the Yellowstone caldera continues to be revealed. Hundreds of shock stations will be installed across the park by 2020. The information from these stations was utilized to map the tremor wave speeds in the subsurface, offering a picture of the magma system's structure. The results indicate that the top of the lava complex is characterized by horizontally elongated areas of localized magma storage, called sills, and that ash is stored in a sheet-like manner instead of being evenly distributed within the rock matrix. After accounting for the textural fabrics, the melt fraction was estimated to be up to 28% in this region of the magma chamber. Standard station maintenance was also included in the fieldwork to guarantee that remote equipment remained working throughout the year. New satellite communications technology was installed at a few locations, providing improved connectivity for some monitoring stations. At Norris Geyser Basin, a brand new monitoring station with microphones that can hear the stream's activity was installed. Number 4. Earthquake monitoring in Yellowstone. The tremor sparked interest in quake monitoring in Yellowstone. The monitoring began in earnest in the early 1970s, when the United States Geological Survey established and administered an earth-shaking network. This network ran until the early 1980s, when it was shut down due to financial constraints. The University of Utah seismograph stations restated and enlarged the network in 1984, and it has been operated by UUSS ever since. The Yellowstone Seismic Network has been updated with complex digital tremor recording technology, making it one of the world's most modern volcano monitoring networks. UUSS now collects data from 46 ground motion sensors in the Yellowstone region. Data is sent from Yellowstone to the University of Utah using a sophisticated radio and satellite measuring system in real time. Since Yellowstone is a high plateau with heavy snowfall and severe temperatures for much of the year, and many data transmission points are located on towering peaks, keeping the data flowing during the hard winter months is difficult. Quake detectors frequently go down for brief periods due to snow and ice on the solar panels or antennas. The gadget that fails throughout the winter can sometimes only be reached in the spring. AD. Hey there. Are you tired of constantly replacing your phone case because it can't handle the wear and tear of daily life? Look no further. Our phone case is not only efficient and durable, but it also adds a touch of finesse and composure to your overall appearance. Just like quake detectors detect waves of tremors about to happen, our phone case recognizes the importance of protecting your device. Don't miss out on this chance to upgrade your phone case. Click on your screen or check out the first link in the description box and get your hands on this special phone case today. Have you witnessed such a shock before? How best do you think people should respond to tremors in order to reduce fatalities? Leave your opinions in the comments section. Also, share and subscribe for more detailed content.